right, thank you very much. Thank you all for joining me. Obviously, someone hates you. You've had two Scottish people in a row, so apologies for that, but I will try and rein in the accent a wee bit. My name is David. I'm in Glasgow, and I'm the founder of the Raw Code Academy. I always like to ask who's familiar with the Raw Code Academy. Basically, just the people I know at the front. All right, cool. I've kind of made it my mission over the last 3 years to help people with event-driven architectures, microservices, and Kubernetes, and now WebAssembly. So if those are things that you find interesting, especially the Kubernetes stuff, check out the Academy on YouTube. There's like over 400 hours worth of content now, which is pretty sweet. And I have to start this talk with a warning because I'm doing some really stupid stuff here. But don't try and ship any of this to production just yet. It is all very, very early. The Dagger stuff I'm going to show you, I know Paul's just kind of presented Dagger, but there's a little bit of Dagger here too. That's relatively safe, still early, but stable, whereas everything else is a bit up in the air. But PHP is a very versatile language, and it is starting to embrace new domains, and other domains are coming to PHP. So, yeah, pinch of salt. Now, the first thing we're going to take a look at is infrastructure as code. Now, I spent about 18 months working at a company called Pulumi, trying to help people with infrastructure as code, and it has a different approach to infrastructure as code than you may be familiar with. I won't ask you to show your hands, but I'm going to assume that most of the people in this audience are relatively familiar with Terraform and have written some HCL at some point in their lives. If you are, then you understand that it's also quite restrictive because of the declarative nature of that DSL. So infrastructure as code is beginning to take on a bit of a new shape, a new meaning, where we're actually trying to do infrastructure as code with real code, not just a small subset of a language that allows us to do some things. Now, Pulumi is probably the leader in this space from a code perspective. Terraform is obviously almost de facto, but Pulumi were the first company to come out with a product that said, let's use real programming languages. Here we have a very small TypeScript example of spinning up a DigitalOcean droplet. Now, Pulumi supports TypeScript, it supports Java, all the .NET languages are supported, it even supports YAML, which is how we're going to do some weird things today. So it has really broad support, but no PHP support. So can we change the way that that works? So we're going to retrofit it with the YAML stuff. Now, this YAML stuff was a bit of a weird announcement for Pulumi because they'd always said that HCL wasn't good enough to do infrastructure as code, so you should use real programming languages, and then they shipped YAML support. But when I was working with them to get this into the feature, I was still at Pulumi at the time, I was like, we can't just support YAML. Because who knows what a YAML anchor is? All right, very few of you. Good. They are atrocious. They're an absolute mess. But it's the only way that you can kind of avoid duplicating loads and loads of YAML within your YAML file. But there's other languages out there that can render or compile to YAML. The one that I use quite a lot is called Q. It's okay if you've not heard of it, but it's a language that came out of Google. It's what they use internally. They call it BCL, Borg Configuration Language, but Q is the open source successor to it, and is now their own company. And I was like, we can't expect people to ship hundreds or thousands of lines of YAML with their Pulumi programs. We have to give them the ability to use other tools. Now, Q is not the only thing. We've got JSON on it, there's Case on it, there's, I'm going to draw a blank, there's DAL, and a couple more. But can we use this to make PHP work? I'm going the wrong way. So let's take a look at some code. Please don't judge me. I don't write a lot of PHP anymore, and I kept forgetting the dollar signs when I was building this. Now, there's a couple of things that I want you to take away from this. The first thing we're doing is I create a class because I'm trying to represent the YAML structure that Pulumi expects in order to do the infrastructure as code. Which is not ideal, of course, because for every resource that we want to deploy, we're going to have to then create a new class, have the correct properties. You know, we could take this further with infrastructure as code, and we could start having enum types for the images and the regions and the sizes and make it very sophisticated, but it is going to be a lot of work. But for this example, we've just created a very simple droplet class where we're able to construct it. Now, this line, I'm sure has caught a few people's attentions. Because of the way the YAML emit PECL module works, the PHP object annotation is basically a string rather than a JSON object. So I have to then encode it and decode it and then spit it back out as YAML. However, what we get is a YAML resource that looks like something Pulumi can deploy, which is kind of cool. Now, because this is code, we can start to do other things. We could also say we're going to add some functions. We could say add a load balancer, and then start to generate more resources. And just all we're really doing, and I know this is very crude, but we're just trying to build an object that looks like the YAML. Now, the way that this works is we come into our pulumi.yaml file here, where we configure a compiler option, and all we're doing is executing the infrastructure.php file to get the YAML. Now, it's not very sophisticated. I'm in the wrong folder. But that's what it spits out. Now, again, the caveat is you don't really want to be creating other classes. Now, there's a really cool thing with Pulumi providers that every single provider has, where they do have a JSON artifact as part of the provider, which is not JSON schema, but it looks like JSON schema. And trust me, I had to fight with the leadership team at Pulumi so many times to just make it JSON schema. But they kept arguing that it wasn't. But what these look like, horrible formatting, like this, kind of JSON schema. So I thought, can we automate the class generation so that the infrastructure as code component isn't that flaky? And it kind of worked. So I wrote some more PHP, which was also very hard. And we're using the PHP model generator, which can take JSON schema files and then spit out classes that map directly to them, which is very nice. As far as the Pulumi schema goes, they're available for pretty much for every single provider. You just need to go into find the schema.json within the resource directory. And then we have to loop over all of the resources and the types within this JSON schema, and then spit it back out as generated code. Now, this function called I hate myself was because I ran into a bit of a problem with this approach. With JSON schema, you have references. And because the JSON schema that's not JSON schema from the Pulumi provider has references, and it's all in one big file, when I map them locally and try to split them out so that I can get the correct IDs and naming of them, all the references then failed to validate, which meant the schema generation failed. So now we have to recursively go over all of the resources and all of the types and string replace the reference string to be a local file string. Now, this was only like 65 lines of code, and again, it's crude, right? But we are able to do infrastructure as code with PHP. This could be much better, and I wish I could show you something better, but I can't. However, we are going to run our PHP program. So on the command line, make that bigger, we can run a Pulumi up. And now it has executed the PHP file, spat out the YAML, and told me that I want to create a droplet. And we could run this. It takes maybe about 2 minutes, but it's not that important. What is important is we can do infrastructure as code with PHP, which is quite interesting, but crude. So, I mean, I do appreciate this is crappy. I don't expect anyone to actually do this. The schema generation gets us so far, but there's a lot more work that we could do here, and it might actually be that there's a better approach if you want to do infrastructure as code with PHP. And I'll talk about some of the ideas there. And if anyone is actually interested in trying to help me build some of this stuff, please reach out to me on Twitter, because I'm very interested in doing this. So, how do we make it better? Anyone heard of GSII? No. OK. Anyone heard of AWS? Of course, right. They are a pretty big cloud provider, and they have a product called CDK. CDK is their approach to do infrastructure as code within their cloud and only worked with their cloud. Now, as part of their CDK project, they built out JSII, which is a compiler toolchain that can transform one language to another language. It allows them to define all of these types and schemas for their cloud products through their emission control API and render out SDKs and languages. Now, they don't have support for PHP, but it doesn't mean that that couldn't happen. And I think that a couple of people could definitely turn this out pretty quickly. And I don't know why all these infrastructure as code tools are always supporting Java and TypeScript and Go and Python and not PHP. I mean, PHP is a large language, but I do appreciate that mostly used for full stack kind of web development. But I want to push it beyond that. So there is an issue for this. It has been open for 5 years, which just tells me they're not going to do it. They just have no interest. But there are people that continue to go on and comment on the issue still to today, and it still gets thumbs up on that issue as well. So 200 isn't a large demand, but people want to do their infrastructure as code as PHP. Is anyone doing infrastructure as code? Not really. Okay. All right. Now, with regards to the Pulumi work, when they launched the YAML plugin, the Java one and YAML one launched at the exact same time. They were actually the first language provider plugins that they shipped that were external from the Pulumi project itself. So there's now a very good process and ability to define new language plugins outside of core and have community-specific plugins. I would like a Rust one, PHP one would be nice too, but there's definitely an option here. Now, moving on from infrastructure as code, we've already seen Paul talk about Dagger a little bit, but Dagger really is going to be the future of continuous integration and delivery workflows and pipelines. Because, again, the exact same problem we have with infrastructure as code, with a DSL or something built on top of YAML, is that it just doesn't scale that well beyond a couple of hundred lines of YAML. Right? This is when anchors come in, templating, we've all seen it, we all hate it, but unfortunately it exists. So, he did cover most of the basics. Oh, there we go. I don't know why it's sometimes up and down. I'll need to work on that. But I'm going to do a little bit of a refresher just so that everyone who wasn't in Paul's talk does understand what Dagger is. Now, one of the questions in Paul's talk was, does Dagger use Docker in Docker? And Paul said no. And he's right. It does not use Docker in Docker. But it's actually much cooler than Docker in Docker. And it uses a project called BuildKit, which allows you to essentially run containers in a containerized environment. It's how Docker build works now, especially with the BuildX stuff. And Dagger is all built on this. Everything that you execute in Dagger runs in a BuildKit layer, and it's powered by GraphQL, or at least the queries are written in GraphQL. Which, when they told me they were going to do the GraphQL route, I said they were insane. But it's actually worked out really well. Because something that GraphQL does really well is allow you to do graph-like queries. And when you want to do workflows, you have a DAG, right? So you have to have a graph, and you can nest your GraphQL. And then the nice part is that GraphQL is a relatively well-typed schema. So they don't actually build their SDKs in the languages. They generate them all from the GraphQL, which is also very low maintenance. So it works out pretty well. Now, there's a new concept in Dagger that Paul didn't touch on that I wanted to talk about a little bit, and it's that they're pushing this a little bit further now. What they've seen in the first 4 years, I mean, it's a new product, but they have been building this for a while now, is that people want to be able to reuse their modules. Like GitHub Actions, right? Nobody actually does download and install Composer. Nobody actually does Docker build. They go to the action and just they do the thing. And Dagger allows you to do that too. And what's really interesting about the way that Dagger modules work is that you could be writing your Dagger workflows in PHP, which are consuming and calling modules written in Rust and Python and TypeScript, and it doesn't really matter because all of the execution happens within the BuildKit layer. So we get this very sophisticated system where it doesn't really matter what your preferred language is because you just use that, but you can still take advantage of the many hundreds to thousands of modules that will potentially exist in the future. I do a lot of Rust Dagger. That's pretty good. Now, then it's definitely the future, and I think the key selling point from Paul's talk was just that one of the advantages of Dagger in this way is the debugging aspect of it. How many times have you done a force push to your main branch because you got a typo in your workflow, it didn't render or whatever? Being able to run your integration stuff locally is very powerful. But there's another thing that Dagger does really well too, and it's that it allows you to codify anything that used to be in a make file could be a Dagger task or a Dagger module. You can even go as far as to replace Docker Compose using Dagger, which means you have one set of instructions for your tests and your tasks all living together side by side with a very strong and consistent cache model as well, so it never reruns the same job twice when the inputs and outputs aren't changed. So there's really nice support where you can say, I want to spin up a Postgres database, I want to wait for it to be healthy, I want to spin up my PHP tests and run them against them, and because it's a graph, it can do all of this stuff in parallel as well. So we can then say, we run all of our tests at the same time, and they've got a nice UI that allows you to build on top of that too. So now we're going to take a look at my Dagger code. Now this is the same infrastructure as code project, but I just wrote a very simple deploy.php that will actually run the Pulumi for us inside of the build kit layer with Dagger code. So all we need to do is pull in the Dagger and connect. It does need a container runtime. So if you're on a Mac or on Windows, it is going to be like Docker Desktop with a virtual machine and then Linux substrate. And on Linux, it can just run directly in the build kit engine. Because BuildKit doesn't have any access to environment variables or the host, we have to manually, explicitly say we want to give it access to the current working directory. That could be a subset or somewhere else. It can even pull in remote URLs and GitHub links and a whole bunch of other stuff. Once we have that, we then create a new pipeline called deploy, where we want to start with a container running the PHP 8 CLI image. We then have webexec, and this is just a Docker file, but codified. Right? This is just, we're running all these commands one after the other until we get what we want. We can set environment variables, we can set secret environment variables, all of the stuff that you would expect. And then we have the Pulumi login, stack in it, and up. And this works. We can do this one of two ways. We could just run PHP deploy, and it will run. Now, what's going to happen there, I'm going to shoot myself in the foot and I'll run it. We're not going to get any output or nothing from this. We have no visibility into this task because we ran it directly with the PHP script. If you want visibility, yeah, that's fine. If we want visibility, we can also execute it underneath Dagger, which then joins the socket and starts to stream all the queries back to us. And we can do no deploy, sorry. And now we can actually see the layers and the transfers and what is happening underneath the hood. So it's a pretty cool tool, and you should definitely start checking out Dagger. And it failed, but I think that's just because I don't have internet, so that's okay. Oh yeah, slides. Now, WebAssembly is something that is very interesting to me, and especially serverless architectures with WebAssembly, because serverless is an interesting pattern because we can deploy without the kerfuffle of having to manage servers, right? It's in the name. But the challenges with serverless too are cold starts are usually the biggest one. Sometimes you could have a 200 millisecond before your container is running. Sometimes it's even longer depending on where you're hosting your serverless workloads. And WebAssembly now is at a very interesting point where it's actually usable, which is a bold statement. I don't know if anyone follows WebAssembly, but it has been very challenging to run it outside of the browser. Now, everyone's browser already supports WebAssembly. In fact, you're probably already using WebAssembly if you use apps like Figma. I mean, Twitter's got some. It's just always there. But of course, there's a lot of perks to WebAssembly. Why would we not want to run that on our own machine outside of the browser? And the challenge is there is that in order to run something as a process, we need POSIX compatibility, at least from a BSD, Mac, and Linux standpoint anyway. And there actually is a very interesting project called WASM, which is the WebAssembly Systems Interface, that wants to give us that similar POSIX experience for WebAssembly binaries. Now, WASM support across languages is really good these days. I mean, I think every language that I work with at the moment can be compiled to WebAssembly and can run or execute WebAssembly modules as well. And the people driving this from the PHP side is actually VMware, which actually confused and shocked me a little bit. But they are working on a lot of WebAssembly language runtimes. Now, there's a few things I think are interesting here. Is one, that VMware make money from selling virtual machines, and now they're trying to move, or at least be supported in the WebAssembly space. Also, the founder of Docker and Dagger, Solomon Hykes, said that if WebAssembly and WASI had existed, Docker wouldn't. That's how powerful that concept of a WebAssembly binary and sandbox could be if we didn't need containers. Because let's face it, running containers on our Mac and Windows machines is exceedingly difficult. So yeah, it's nice to see VMware doing this. They support a whole bunch of languages. PHP is there. And the perks, and I think why VMware are interested in this, is that we can run truly portable code with WebAssembly. WebAssembly execution happens in a sandbox that has no access to file systems, it has no access to networking, it has no access to signals. Basically, you can't write anything good with it. But again, this is where WASI comes in. So, while this is great in a browser that we don't want it to have access to our file systems, if we want to write back-end services, that has to change. The WASI project has been a thing now for probably about the last 5 years. But what's exciting about WASI at the moment is that they made a radical shift in the way that WASI works. Previously, what they wanted to do was build a monolithic WASI that provided complete POSIX compatibility for any WebAssembly module. However, the challenge there is you get one specific implementation that then removes that truly portable aspect of it. We can't guarantee the same networking and syscalls are going to work on Linux and Mac and Windows. But with WASI Preview 2 is the first time they've said, OK, we're actually not going to have any implementations by default, and we're going to rely on something called the component model. Now, the people in the WebAssembly space are now providing components that satisfy all the interfaces defined by the WASI spec for sockets, etc. This means that you can have a WebAssembly module and a WebAssembly runtime, and you could provide a database abstraction interface and say, this is how we speak to a database. And you can swap that out whenever you want, and your code doesn't have to change because you're relying on a single interface and API, which is really interesting. Now, the only components we have so far with WASI Preview 2 is the I/O file system stuff. So yes, we can open files and directories, etc. Clocks, which is quite handy to have. And of course, randomness, HTTP, and sockets. This is now the fundamental layers that you need to build any backend service, right? Beyond this, anything else is just syntactic sugar, like the database abstractions, making it easy to speak to Redis without having to understand how you speak to Redis. The goal being we could provide a KV component, and you can swap out the Redis backend with something else, like MongoDB or SQLite, and it would just work. This is very new as well. So WASI Preview 2 has only really been a thing for less than a week. But it is a major turn-in, or major step forward for what we're doing with serverless and WebAssembly. Now, you might be thinking, we've already got Lambda, we've already got Breath, we can already do serverless with PHP, why do we need WebAssembly? Well, WASM modules can be executed in nanoseconds. We don't measure it in milliseconds. What I mean by that is when we have a WebAssembly runtime that is able to execute WebAssembly code, and you say invoke this application, it usually takes less than a millisecond, always takes less than a millisecond to measure it in nanoseconds. You don't get that with containers. Containers are inherently slow because we have to work with the POSIX API, we have to set up the sandbox, the networking, etc. There's no containers or cold starts, which is a big advantage to WebAssembly. Cloudflare are betting quite heavily on this as well. I don't know if anyone's using Cloudflare workers, but you can deploy WebAssembly modules there. And it is truly portable. The WebAssembly virtual machine runs the exact same on my Mac as it does on Linux and it does on Windows. So I'm not having to rely on any virtualization whatsoever except for the WebAssembly instruction set itself. And the local developer experience of that is very subtle, but not having to do a Docker compose up when I'm building an application really does make my development life just a lot easier. And we'll see that as we start to explore one of the projects that allows us to do WebAssembly. And I think this is understated, right? And I won't ask you to show your hands, but you can feel guilty, right? Who's pushed a bigger than 1 gig Docker image? I said don't show your hand. But we've all done it. We've all shipped massive container images, and we just rely on caching, and we make it work in production because we don't really think about it. But if you are new to a project and you do a Docker Compose up, you could be sitting there for minutes waiting for this stuff to download, especially with the larger images. WASM modules don't really need to care about any of this. Most of my WASM applications that I have built are smaller than 5 meg in size. And these are real applications that do real things and speak to databases. 5 meg is pretty good. I want more 5 meg stuff in my life. All right, let's have some WASM fun. So, code. I've got a few examples here. We're going to be using a project called Spin, which is from the company Fermion. And unfortunately, it relies on TOML for configuration, which I generally think is the worst language ever. It's just this weird array syntax that gets me every time. Anyway, I'm not going to rant about TOML today. We're configuring this to run in a slightly unique way from most Spin applications. So let me run you through the nice way. I guess that's the best way to put it. We can run spin new, and we get a whole bunch of templates that we want to use. There is an HTTP PHP one here, but we're going to do something else first, because the way the PHP implementation works is a little bit different. So let's do Rust. Did I mention I like Rust? So now we have this Rust directory, which just has some Rust code. Not colored, I'll show you in a second. And we can run spin up. Oh, I'm not. How have I broken it? I just created it. No such file or directory. Interesting. OK, let's not look at the Rust one. Let's go back to PHP. So they have the thing I was going to show is that the Spin project has an SDK specifically built for Rust and for .NET, Python, and Java, I think. Again, no PHP. However, they do have this WAGI project, which is called the WebAssembly Gateway Interface, which is essentially just the WebAssembly CGI, that allows us to do execution with a PHP runtime for WebAssembly. Now, this just means that we're a little bit restricted in what we can do because we cannot access the Spin SDK. But that will hopefully change very soon. So this is the executor here is the weird part, but that we're just going to kind of skip it over. Now, what's really nice about Spin, WebAssembly modules don't have any ambient authentication whatsoever. They can't make networking requests. They can't open files on disk unless you allow them to do so. So one nice little bit of configuration here is you can actually enable TCP traffic or HTTP traffic by allowing outgoing hosts, and that would just be setting it to google.com or whatever you're going to be querying, which is a nice little touch. Now, because we're using a different executor, we do have to pull that in, and we're using the VMware WebAssembly language runtime for PHP. So basically, you just have to copy and paste this bit and stick it in all your spin.tomls. And just yesterday, because I was moaning to the team, when you run spin new for PHP template, you will get this by default. That wasn't the case. Now, I'm trying to tidy up things a little bit, so we add on a component called a redirector. So this is another WebAssembly module that monitors for traffic coming in on slash and redirects it to index.php because we have to point it to the right file that we want to serve. So if we go to spin PHP1 and do it spin up. And localhost. We get the greatest PHP program ever written. Hello. Not very exciting, but What's interesting here is just the fact that this code is being executed as a WebAssembly module on my local machine with all of those fantastic performance and optimized characteristics we get from the small binary size and no ambient authentication, which makes me happy. Now, we've got another example called PHP 2. Oh, I never even showed you the code from the first one, sorry. It's just echo. All right, so in PHP 2, we're just using more PHP stuff. So here we're setting a header so that we can do a JSON encode and return a JSON response. So we can run spin up. We refresh, and I broke it, probably because I was making changes. Oh yeah, that's from another example. I'll show you that in a second. There we go. And now we've got a JSON out. Again, not very interesting. You're not going to make any money by shipping an application like this. But it is running in a WebAssembly sandbox. So let's take a look, because I'm sure someone is thinking, hopefully, my applications have dependencies. How do we work with Composer? How do we use other libraries? I'm not going to write all my own code. So PHP 3, we are using auto-loading, pulling in a faker project, and then spitting out some random data. Now, there is a few tricks you need to do, or one trick specifically to make this work. There we go. The way that the bundling happens within the WebAssembly module, we do either need to deploy the entire PHP 3 directory or move the vendor folder into the source folder, unfortunately. In order to make that work, it's just a one-line change in our composer, I guess a three-line change, but we're just setting the vendor there within the config so that it gets put into the right place. Otherwise, the dependencies won't resolve in the WebAssembly execution. Now, because the Rust demo worked, I'm not really feeling very confident about the next one, but we'll certainly give it a try. Now, this is just Hello World. But building your applications with Spin, there's a really cool feature that I'm a fan of. So let's go to PHP 4. So Spin changes the way that we could build microservice-based architectures in a way that we can isolate them as individual WebAssembly modules that are executed by the runtime on demand. And what's actually happening when we curl to this Spin application is the runtime runs the module in nanoseconds and gives us a response. There's no reason we couldn't have 1,200, 2,000, or 20,000 modules in a single Spin application, besides obviously the deploy would take a bit longer. But where it gets very interesting is that every single one of those modules could be written in a different language and still communicate and speak to each other. So there's a Spin command called spin add. And we could say we want to add a Rust. Well, that didn't work, but let's see what happens. And we'll just call this Rust. And we can set the path, right? So the ... just says, can I capture everything? We can say this module responds only to the Rust path. And then we get over here a new directory with a Rust application, which can be deployed side by side with our index PHP. Now, if it works, interesting. All right, let's delete Rust. Maybe it's just the Rust one that's broken. We can try another language. So I deleted their directory, but I now have to remove the component from here. And then we'll do a spin add. Now, the reason I always do Rust for spin add is because the way these templates work, they're actually componentized as well. And not all of them have an add handler, which sounds very weird. But let's see if we can do Go. Spin up. I know what I'm doing. I'm just being a bit... All right. Funny story. The reason the Rust one wasn't working is because I'm an idiot and forgot to run a spin build, because PHP doesn't need that because it's interpreted. So let's try one more time, and then I'm giving up. Rust. Rust, spin build. Right, tether. Oh, it's getting there. Okay, cool. Oh, come on. Moving on. Now you want to do a software update. Thank you. You're just going to have to use your imagination here. We can add many components and many languages, run a spin build and a spin up, and they become available. Now, you might be thinking, how do I run this in production? So we'll do one quick thing. I'll jump back to PHP 2, and we can do a spin deploy, network depending. And it just sticks it up on their serverless platform, which is free for up to 5 applications and very limited restrictions. Very generous restrictions. And it's available, hopefully. Anyone got 5G? Well, it's getting there. Probably help if I took my phone out of my pocket for the connection. But. There we go. All right. Nice and simple, but it is available on the public internet on fermion.app. This isn't a pitch for Fermion. They don't pay me any money. I just really love Spin. I like the way that it changes the way we can build services. And they've got really great integrations with Redis and a whole bunch of other cool stuff. So definitely check it out. All right. So it doesn't have first-class support. We are using that waggy interface. But this is something that is going to change. I already told you what waggy is. It's fine. Now, there is one other aspect of WebAssembly that I haven't really covered, and that's because, well, it's extremely broken right now. But WASM is a WebAssembly runtime, and they do have a PHP extension. Unfortunately, it hasn't really been updated in like 3 years now, but there have been conversations happening to get that alive and kicking again. But this would just allow you to execute WebAssembly modules within your PHP code. So you can start to write, maybe you've got some things that need better performance or better memory management. You want to write them in Rust, ship them as a WebAssembly module, and execute them within your own PHP code. Especially if you've got existing applications, legacy applications, it's a pretty good use case. The way this looks, and I can't run it. Again, it's very, very broken. No, not that one. WASM or PHP. Examples, and here. Now, you don't have to know what is. It's just a WebAssembly text representation, so you can actually ship WebAssembly modules as this, and they can be executed. But this could be loading bytes from a remote URL. Maybe you store your WebAssembly modules on GitHub Container Registry, which supports a whole bunch of stuff, or S3, whatever. But it's nice that we have that. Well, hopefully, when they fix this up, there has been conversations, people can start to do that as well, which is cool. Where's my terminal? There we go. OK, now this is just a very quick point, because it just makes me smile when I see it. But has anyone ever wanted to replace their JavaScript on a web application with PHP? Good. It's possible. So here is my index.html. Now, what is really cool about this is that the PHP interpreter has been made available as a WebAssembly module. So we can then pull that in, either via an npm package or just using CDN, and then have a script of type text PHP and run any arbitrary PHP code that we want, And we're just using this data annotation to tell it where to put the output from that script, which is just into a div called output down here. So if we come back up, we can open our thing. And it's not the fastest, but we now have PHP info delivered via a WebAssembly module in our browser. Ridiculous, right? I'm going to take it a step further. So this is the PHP WASM. This is how this is actually supported. This project has a demo page where they do some really weird stuff. So obviously we got hello world. Oh, come on, connection. Oh, there we go. So there we have hello world. But my favorite one, Drupal 7, being executed with no server in the browser with a PHP WebAssembly interpreter. Come on, that's impressive. So WebAssembly is exciting. I hope some of you share this excitement now. I think the possibilities are very, very cool. So in summary, I know a lot of this wasn't really practical, and it's not something I expect people to walk away and start playing with. But there is a bright future for PHP beyond just the full stack that we have today, and I think that full stack will be a lot more things in the future from our infrastructure provisioning and even inside of the browser. So infrastructure as code is definitely under construction. Pulumi, hopefully we get a community provider. I really want to see the JSII implementation to allow us to use Terraform CDK. But there's potential there. CI/CD and serverless with WebAssembly, I think, is just go, right? This stuff is already great. Dagger with their generated SDK, which we've seen a couple of times, is great. And Spin R, with the Fermion team, and Spin will be supporting PHP without the WAG8 extension and giving us a proper execution there too. That just needs a little bit more time. And in the browser, yeah, again, maybe not that practical, but fun, and you should definitely go and play with it. Thank you for your time. If anyone has any questions, I'd be happy to take them now. Any questions?
I think, as far as I know, with is it WASM? Like this, well, the thing which puts that you can allow WASM to PHP. My understanding is that the company that provided a lot of the runners basically kind of went bankrupt, or like something around these lines. That like the main contributor like left because he was doing a lot of the runners for a lot of the languages. So I think that's the main reason why it's been abandoned for 3 years. So that's the main clarification just there.
Yeah, I mean, WASM isn't the only runtime for WebAssembly. There's at least half a dozen of them now, and a lot of them are funded with people working on it full time. And I think it's just interesting to see that there have been some conversations. I'm hoping people will take that work and bring it to the other runtimes. The WASM Edge is probably one of the leading ones right now. So getting PHP support into that would be pretty cool.
Yeah, it's just I think like the person who was doing the runner basically was hired by the company and like left due to reasons, and I think he explained it on the blog post. Yeah.
Any further questions?
In the example you showed of a PHP application running in WASM, is the PHP being compiled at all, or is it just that the interpreter is compiled to WASM and it's reading the PHP file?
PHP is not compiled at all. It's mounted into the WebAssembly module and then executed with the PHP compiler rendered as a WebAssembly module.
So the size of that's going to be pretty consistent, right, in terms of file size. Is there anything in the future where we can just dump our PHP scripts to WASM directly?
It doesn't exist now, but yeah, it could.
Any more? No, I think we're done.
All right.
Thank you, David. Cheers.